All right, get ready for this one. Someone sent in this article from American scientist all about the history of vacuums.
Vacuums.
Vacuums. And it's honestly way more interesting than it sounds.
I mean, a vacuum is just, well, nothing. Right.
Exactly. And that's what makes this so fascinating. We're going to dive deep into how people have, thought about and dealt with this idea of nothingness going back centuries.
I'm intrigued already.
And get this, the pursuit of this perfect vacuum, this ultimate nothing, actually led to so many inventions we use every day, like barometers, light bulbs, even vacuum cleaners.
Okay, now you've got my attention. So where do we start with this history of nothing?
Well, the author actually kicks things off with, remember Felix Baumgartner?
Yeah.
The guy who did that crazy space jump a few years back.
Oh, yeah, the one where he jumped from, like, the edge of space.
Exactly. The author was talking about how he kind of envied Baumgartner, actually getting to experience that vacuum of space.
I can see why.
It really makes you think, like, what is space,
right?
Really? Is it truly nothing?
That's a question philosophers have been grappling with for ages. I mean, even Aristotle, way back in ancient Greece, believed that, and I love this quote, nature abhors a vacuum.
Nature abhors a vacuum. So they thought there had to be something there filling that space.
Right. To them, the idea of a true void was, well, impossible.
So what did they think was filling this void, if not, well, nothing?
They came up with the concept of ether, this mysterious substance they thought filled the heavens and, the rest of the universe.
So like an invisible ocean in space. What did they think this ether did exactly?
They believed it was this medium that allowed things to happen. Like, for example, they thought ether was what allowed light from the stars to travel to Earth. And it even, they believed it held the planets in their orbits.
Okay, so it was this invisible force that connected everything in the universe. That's pretty out there.
It was. I mean, it was their way of trying to explain how things could interact over these vast distances when there seemed to be nothing between them.
Makes sense. So how did they go about trying to find this ether? Something that's supposed to be nothing. Did they ever actually find it?
Well, the search for ether really took off with a student of Galileo, a guy named Evangelista Torricelli.
Another Italian. Seems like they were at the forefront of a lot of early science.
They were. Anyway, back in 1641, Torricelli was experimenting with mercury and kind of stumbled upon something amazing. He accidentally created a vacuum.
Wow, on accident. So what happened?
So he took this tube of mercury and flipped it upside down in a bowl, also filled with mercury. He thought that because of gravity, all the mercury would flow down into the bowl, right?
Yeah, seems logical. What happened instead?
Well, the mercury did fall a bit, but then it just stopped, leaving this gap at the top of the tube. And guess what? That gap was a vacuum.
Whoa. So he just, made nothing appear.
He did. It was a huge deal because even though it didn't prove the existence of ether, it did lead to the invention of something we still use today, the barometer.
Wait, the thing that predicts the weather. So predicting the weather came from this attempt to find this mysterious ether.
It did. It's a great example of how scientific discoveries often happen in the most unexpected ways.
So how did he get from a vacuum to a weather predictor?
It's all about air pressure. See, what Torricelli realized was that it wasn't ether holding the mercury up in the tube, it was the weight of the air pushing down on the mercury in the bowl.
So the air around us, it has weight. It's not just empty space.
Exactly. And the weight of that air, what we call atmospheric pressure, changes depending on the weather.
Okay, I'm starting to see the connection here. So high pressure means good weather and low pressure means rain.
Exactly. All thanks to this attempt to find this mysterious ether. I mean, isn't that wild?
It's incredible. We can predict the weather because of this quest to find something that, well, wasn't even there. But what about this ether idea? Did people just give up on it after this?
Not entirely. Even after Torricelli's discovery, a lot of people still believed that something must be filling that vacuum, including the alchemists.
Okay, now things are getting really interesting. Alchemists. Those were the guys who are all about magic and turning lead into gold, right? What do they have to do with vacuums?
Well, they had their own name for this mysterious substance, quintessence. It was basically their version of ether. They believed that it was like the key to understanding the universe and unlocking all its secrets.
And how did vacuums fit into all of this?
They believed that this quintessence was somehow connected to a vacuum. Like if they could isolate this nothingness, they could harness the power of this quintessence.
So they were trying to isolate nothingness to achieve ultimate power.
Kind of. They thought that quintessence could do all sorts of amazing things, like cure illnesses and, yeah, even transmute base metals into gold. It was like the holy grail for them.
I never knew the idea of nothing had such a, profound history.
It really does. It's this concept that has fascinated and frustrated scientists and philosophers for centuries. And this quest for a vacuum, well, it takes a more mechanical turn thanks to this guy, a mayor in Germany named Otto von Guericke.
Hold on, a mayor? I thought we were talking about alchemists and philosophers
Yeah,
here.
right. He was a man of many talents. Von Guericke was absolutely determined to, create a vacuum on purpose and prove its existence. And to do that, he invented a very important device, the air pump.
So is that like the first vacuum cleaner?
Not quite, but you're getting warmer. It was more like, think of it like a bicycle pump, but in reverse. Instead of pushing air in, it sucked air out.
So he was the first one to really make a vacuum, intentionally. What did he do with it?
He came up with this really spectacular demonstration to show just how powerful a vacuum could be. It involved these two large, they were made of bronze hemispheres.
Hemispheres, like half sphere.
Exactly, called the Magdeburg hemispheres.
Yeah.
He joined them together, created a vacuum inside them using his air pump, and then, get this, he harnessed 2 teams of 8 horses, 1 team to each hemisphere.
Wait a minute, I've heard of this. He tried to pull those hemispheres apart with the horses, right?
Yep. And it was amazing. No matter how hard those horses pulled, they could not separate those hemispheres.
So what was holding them together? Was it like some kind of mystical force from this vacuum he created?
Nope. It was the air pressure outside pushing those hemispheres together. Because there was no air inside to push back, they were stuck fast. Von Guericke basically showed everyone the power of atmospheric pressure, but in this really dramatic way.
That's incredible. So did this finally convince people that there was no ether?
It's funny, even with all the evidence, some people still clung to the idea of ether. But, von Guericke's air pump, it really opened up this whole new world of scientific investigation because now scientists could, create these vacuums and study how things behaved in this seemingly empty space.
So they were actually using nothing to study, everything.
Exactly. And it led to some pretty amazing discoveries, like the fact that sound doesn't travel in a vacuum, but light does.
No way.
Yeah.
So you're telling me that I couldn't hear you if we were in a vacuum together, but I could still see you?
Exactly. It was a mind-blowing discovery at the time.
I bet. I mean, what did scientists make of that?
It really got them thinking. It suggested that, light was somehow connected to something more fundamental than air, something that could travel through both a vacuum and space. So the idea of ether was still alive, but it was evolving.
This is all pretty intense stuff. Any visuals to help us, wrap our heads around all of this?
Well, there's this famous painting that really captures the mood of this whole era of scientific discovery. It's called An Experiment on a Bird in the Air Pump by Joseph Wright of Derby.
An experiment on a bird in the air pump. Okay, that sounds a little intense.
It is, but it's incredibly powerful. It shows a group of people gathered around, and the scientist is removing air from a glass jar that has a bird inside.
Oh, wow. Okay. Bit dark, but definitely memorable.
It really highlights both the fascination people had with scientific discovery and the questions it raised about, ethics and the limits of experimentation.
It definitely makes you think. It seems like this pursuit of a vacuum was really picking up steam at this point. But did it lead to anything more practical? I mean, anything beyond just philosophical debates and experiments with birds?
It absolutely did. In fact, this quest for a perfect vacuum would soon illuminate our world, quite literally, through the invention of the electric light bulb.
Now, that's what I'm talking about. From the void to, bright lights. Who would have thought?
It's amazing how these seemingly unrelated pursuits can come together to create something truly revolutionary. But that's a story for our next deep dive into this fascinating history of nothingness.
Okay, so for vacuums to light bulbs, that's quite a jump. Did someone just suddenly have this light bulb moment? Like, hey, I know, let's stick some wires in a vacuum, run some electricity through them and see if it glows.
Well, it wasn't quite that simple, but you're on the right track with the whole wires in a vacuum thing. Remember how scientists were using those air pumps to create vacuums in those glass containers? Well, they started noticing that if you put a metal wire inside and ran an electrical current through it, the wire would heat up and, glow.
So the first light bulbs, they were basically just wires in a vacuum. I had no idea.
Pretty much, yeah. But there were some pretty big challenges to overcome. Like if you wanted to create a light bulb that could actually replace, candles and gas lamps, it had to last for a while. And the wires they were using, they just couldn't handle the heat.
How hot are we talking here?
To get a good bright light, over 1,500 degrees Celsius.
Whoa, that's incredibly hot. So what did they use for these early filaments?
Well, they tried a few things like platinum because it has a really high melting point, but even platinum would, vaporize after a while at those temperatures, so the bulbs wouldn't last very long.
Plus, wasn't platinum super expensive back then?
It was, so it wasn't really a practical solution for, lighting up the world.
Back to the drawing board then. What was the next big breakthrough?
Well, a British chemist and inventor, Joseph Swan, he came up with a pretty brilliant idea.
Okay, let's hear it.
Carbon, specifically graphite.
Graphite, like what's in pencils.
Exactly. And here's the thing about carbon. It doesn't actually melt. It needs to reach over 3,600 degrees Celsius before it turns directly from a solid into a gas.
Sublimation.
Yes. So you would think problem solved, right? Graphite filaments, everlasting light.
Sounds good to me. What was the catch?
Those imperfect vacuums, they created a whole other problem. See, carbon, it reacts pretty easily with oxygen. And even though those air pumps were getting better, there were still tiny amounts of oxygen left inside the bulbs.
Ah, so close. But those little bits of oxygen would still mess things up.
Exactly. It was this constant battle against impurities. But over time, vacuum technology kept improving, getting better at removing those tiny bits of oxygen. And eventually, they created a light bulb that could, burn brightly for a reasonable amount of time.
So they figured out how to get rid of those last little bits of oxygen and boom, light bulb. It's crazy how these tiny little details can make such a huge difference.
It really is. But what's even more interesting is that the guy we most associate with the light bulb, Thomas Edison.
He didn't actually invent it, right? He just, improved it.
You got it. Edison, he saw the potential of electric lighting, and he really focused on refining that manufacturing process and figuring out how to market these light bulbs to, the masses. But, and this is where things take another unexpected turn, one of Edison's failed experiments actually led to another huge invention, the vacuum tube.
Hold on, a failed experiment. You're kidding, right?
Nope. He was experimenting with these light bulbs, and they noticed something really weird. A bulb with a broken filament, one that shouldn't work at all, could actually still conduct electricity, but only when the filament was hot.
What? How is that even possible? I mean, the filament was broken.
Right. It seems totally counterintuitive, but what they realized was that the heat from that broken filament was actually allowing electrons to, jump across that gap.
Wow, so a broken light bulb led to a whole new discovery about how electricity works.
And it gets even more interesting. They figured out that this flow of electrons only worked in one direction, like a one-way street for electricity.
Okay, a one-way street for electrons. What do they do with that?
It was huge. This discovery led to the development of something called the vacuum tube. It's basically a device that can control the flow of electricity with, incredible precision.
So like a valve for electricity.
Exactly. Turning it on and off, amplifying it, tuning it, you name it.
So this vacuum tube basically paved the way for, everything electronic, right?
Pretty much. Radios, televisions, telephones, even early computers, they all relied on these vacuum tubes. Remember those big old clunky TVs we used to have? The ones with the curved screens?
Oh yeah, those things weighed a ton.
They did. And that's because they used this giant vacuum tube called a cathode ray tube to create the images on the screen. And they had to surround those tubes with all this lead shielding to protect us from the X-rays they produced. Hence, the weight.
Wait, X-rays, like the kind you get at the dentist, those old TVs were shooting X-rays at us.
Well, not exactly. I mean, the lead shielding absorbed most of them, so they were considered safe. But it's a good reminder that even these seemingly simple technologies can have, unexpected consequences.
No kidding. But what happened to those giant vacuum tubes? I mean, we don't see them in electronics anymore.
Right. They were bulky, they were fragile, they used a lot of energy. So eventually they were replaced with something much better. Silicon chips.
Ah, the silicon chip.
Yeah.
Much smaller, much more efficient.
Exactly. And these tiny chips, they revolutionized electronics and computing.
And are these silicon chips made using vacuums too?
Absolutely. In fact, they have to be manufactured in ultra-high vacuums. I mean, we're talking about vacuums that are even more extreme than those needed for light bulbs. Because any tiny impurities from the air, they could contaminate those chips and make them, completely useless.
So even though we don't see them, vacuums are still absolutely essential to our modern world.
More than ever. It's pretty mind-blowing when you think about it. This whole quest for a pure vacuum, something that started with alchemists trying to unlock the secrets of the universe, has led to the technologies that, power our world today. It really makes you wonder, what is nothingness, really?
It's amazing how our understanding of nothing has changed over time. We went from this idea of a mysterious substance, this ether, to the realization that a true vacuum, this space, totally devoid of matter, is incredibly powerful and crucial to, well, pretty much everything.
It is. And speaking of everyday technology, you mentioned vacuum cleaners earlier, right?
I did. The humble vacuum cleaner. It's proof that a vacuum can be pretty powerful. But before we get into that, let's talk about what happened to that idea of ether.
Right, ether, that mysterious stuff that was supposed to be all over space. But you said Einstein kind of blew that whole idea out of the water?
Yeah, with his theory of relativity. He basically showed that we don't need this ether stuff to explain how things work, like gravity or light. In fact, his theory actually proved that nothing really does exist.
And that it's actually essential to, well, everything.
So after centuries of searching, scientists realized it was nothing all along. It's kind of funny when you think about it.
It is, but it's this nothing that's full of potential. I mean, think about it. It's that nothing inside a light bulb that allows electricity to flow and create light. It's the nothing inside an X-ray tube that lets doctors see inside us. And yeah, it's the nothing inside a vacuum cleaner that helps keep our homes clean.
Okay, now you're talking. Let's get to those vacuum cleaners. I have to admit, I've never really thought about, the science behind them. It seems so simple. Does it really just suck up the dirt?
Well, not exactly. It's more about using air pressure in a clever way. See, the vacuum cleaner, it creates this low pressure area inside, like a mini vacuum.
Okay, so a low pressure zone. Then what?
Well, nature, it wants to equalize pressure, right? So the higher pressure air outside, it rushes in to fill that void, that low pressure area inside the vacuum. And as it rushes in, it carries all the dirt and dust with it.
So it's not really sucking, it's more like blowing. That's pretty wild.
Exactly. It's all about those pressure differences.
It's amazing. We took this idea of a vacuum, something that, puzzled philosophers for ages, and turned it into a household appliance.
And it's not just any appliance, it's one that really changed things, socially.
Really? How so?
Well, think about it. Before vacuum cleaners, housework was incredibly time-consuming. It was often seen as, women's work, and it took hours and hours to properly clean a home.
Yeah, I can imagine. No one likes sweeping. So the vacuum cleaner was like a huge time saver.
It was. And that had a big impact on, well, everything. I mean, suddenly women had more time to, pursue other things like education or careers, or even just relax a bit.
Makes sense. It freed up a lot of time.
It did. And it also meant that everyone in the household could share the responsibility of cleaning, which, was a pretty big shift in how things were done.
It's incredible. I never would have guessed that vacuum cleaners played a part in changing, social norms.
It's a great example of how these technological innovations, they can have ripple effects that go way beyond, their original purpose.
So it's safe to say we've come a long way from those ancient philosophers pondering the void.
We have.
I mean, we've seen how this quest to understand a vacuum led to breakthroughs in, weather prediction, electric lighting, pretty much all of electronics, even, how we clean our homes. What's so fascinating is that something that doesn't even seem to be anything actually has the power to do so much.
It's true. It makes you wonder, what other unseen forces are out there, shaping our lives in ways we don't even realize? What if there are other kinds of nothingness out there, just waiting to be discovered?
That's a great question to leave our listeners with. Every time we think we've figured out nothingness, it seems like it surprises us with even more possibilities.
It always does.
Well, that's it for today's deep dive into this surprising history of nothing. It's been, enlightening, to say the least, and it's clear that nothing is actually something pretty extraordinary. Until next time, keep exploring, keep questioning, and never underestimate the power of the void.